This is Greg Trauthwein with Offshore Engineer TV, and we're here at OTC with Chris Myers and James Caldwell of Titomic, and we're here to talk about some cold spray technology. So, Chris, to start us off, why don't you give us by the numbers look at Titomic today, just something that gives us size and the scope of the operation.
Certainly, thanks for the interview. Excited to be here, excited to be at OTC. Titomic is a cold spray company, started in Australia, a publicly listed company in Australia. We've purchased a company in the Netherlands, and then we're opening U.S. operations in Huntsville, Alabama. So a 60,000 square foot factory will open in Huntsville, Alabama on June 2nd. We're gonna build the cold spray machines. We're gonna have a line for repair parts, and we're gonna have a line to make brand new parts. Very excited about that. So we'll have a 20,000 square foot facility in the Netherlands, opens on September 5th. We're expanding our Netherlands operation, and we've got a lot of R&D work as well as production in Australia as well. So we're very excited about Titomic's next step of opening U.S. operations. And James will go through what cold spray is, but essentially for oil and gas, cold spray is additive manufacturing. So it's new manufacturing. We can do parts faster, titanium parts faster than traditional manufacturing. A lot of times it's hard to get one titanium part, hard to build, it's expensive. We can knock it out in hours, give it to you, look at it. You want 10 more, we'll print 10 more. So additive manufacturing really makes the manufacturing process faster and less expensive. We can also do repair of parts. We have 9 machines in war right now repairing battle parts in Europe. And then we can also do anti-corrosion, which is perfect for oil and gas. And we have a collaboration with Woodside in Australia, an offshore oil company, and we're doing anti-corrosion there. So it's a lot of fun, a lot of excitement going on.
Okay, well, anti-corrosion and efficient manufacturing are something that's definitely going to perk the ears of offshore engineers. So,
absolutely.
So, James, could you, I guess, take a bit of a deeper dive just into cold spray technology, specifically what it is and where we find it?
Yeah, sure. So basically what we do is we get a fine metal powder, almost like a talcum powder. We inject that into a supersonic gas stream and then fire out the end of a nozzle. So what that does is it plastically deforms, much like a tennis ball hitting a wall, and then the particles build upon each other to create a solid material like you'll see here. So you can either use this, as Chris mentioned, for additive manufacturing of parts, like you'll see this titanium flange here, or you can use it for repairs and coatings. So you might see something like this where you could have a defect in your profile, you can then rebuild that material and remachine it and get that back into service.
This is 2 different metals, which is unique as well. James, why don't you take him through what those metals are?
Yeah, so basically what we've got here is a carbon steel with a copper layer on the top. So you could use that for wear resistance. What we've seen as an incredibly good use case for dissimilar metals in the oil and gas industry is aluminium on carbon steel. So what that does in a salt water environment is it provides cathodic protection for that carbon steel, and then creates an oxide layer over the top of that aluminium. And what that does is you're looking at about a 30 to 40 year lifespan. So rather than having to recoat those parts yearly or potentially within 4 years with a polymer or a paint, it's more of a coat once and leave it for the rest of the asset's lifespan.
So we're also looking at helping bridges. The Army Corps of Engineers, all the bridges we have in our U.S. infrastructure to do anti-corrosion there. So that's another application. And one of the interesting things about our particular cold spray technology, we can do very large parts. Since the way our technology works, the nozzle, as it sprays the part to make it, the nozzle moves, the part remains steady. So that means we can make very large parts because our nozzles easily move. If you have to move the part, you'd be restricted on the side. So we can make parts up to 9 meters long, so very large. Large valves for the oil and gas industry, flanges, we can do hatches, all brand new, make them quickly. Because you're not ordering 6,000 parts like you are on a car, right? You're ordering 1, maybe 3. That's going to be expensive if traditional manufacturing has to do that, where we can just nail it out with the automated machine. So very exciting technology for oil and gas right now.
When you look at the technology and its application in oil and gas and defense and maritime, what is the real value proposition? I know we were talking before about the ability to use this on rigs where hot work might have to shut down operations. So when you're talking to someone who's operating a facility offshore and you know they need to keep that facility working to continue to make money, what are the value proposition?
Yeah, so basically our clients have been working with over the last 2 years in developing this use case. Have found that 1, you're operating under 550 degrees, so you're not risking those potential flash ignition of the methane and the hydrocarbons. 2, surface preparation is very minimal. So we're seeing our bond strengths comparative to traditional ways of coating these assets is much, much higher. So that means that we don't have to prep the surface quite as in terms of abrasive blasting, which can be a problem in certain areas on the platforms, around instrumentation. There's also the need for removing that media. And then 3, it's ease of use. So, we can hook these things up to a compressor, our portable systems. At 20 bar of pressure, we can spray a plate 300 by 300 millimeters in about 5 to 10 minutes. Incredibly easy to use, so minimal training required for the operators as well.
So put succinctly, we can be on platform. You don't have to shut the platform down because it's cold spray. It can be done very quickly, efficiently, and you don't have to send parts off the facility. So everything can be done while you're operating on offshore. For aerospace and defense, very similarly. If I had to repair a part and take it offline and go back, it shuts things down if I don't have a part right away to replace. This, I can repair the part on the ship without impacting its mission. Same thing on ground forces. You get bullet holes in a vehicle or something, I could just repair it in field. I don't have to send the truck back or a part back to put that out of harm's way. I can do it in harm's way, fix it. A big deal for operating in theater in terms of battle from that perspective. And also just brand new parts, like I said. Often if you want to do one part and try it out, a titanium part will cost a fortune and take like 17 months to do one part because they're very busy. We can knock it out in hours. You like the part, great. You don't like the part, you want to fix it, you want to change it. We can do all that in hours, the turnaround cycle, and get them out to you. So this additive manufacturing and this efficiency of repair really helps your bottom line.
When you look at the two parts of your business, you have the new parts manufacture and you have the repair. What's the big driver for your business today, and how do you see that going forward in the coming, say, 12 to 24 months?
Well, we want to do 50-50. We want to do both, right? So we're doing a lot of repair work now, but we're also getting contracts to do additive manufacturing, because that is a big deal right now in the U.S. defense business as well as the global aerospace. So I think we're looking to see both. And then also, as James mentioned, on the anti-corrosion, not even just repair parts, just making sure that corrosion on an offshore rig or on a U.S. Navy vessel or on any kind of thing that's in the weather, we can do that all repaired there or anti-corrosion there, and it lasts for quite a long time. So we're trying to do all 3 parts of the business at the same time.